Bismillah ar-Rahman ar-Rahim. There's a question, October 2020, and variant 43. Question is 4. Two small smooth sphere AB are equal radii and mass is a 4 kilogram and m kilogram. Okay, so one is a 4 and one is a m. So let's start. And best technique when you do this kind of question, read and write. Okay, so one is a particle and one is a B particle. There's a 4 kilogram here, and there's m kilogram here. Okay, and initially B is at rest. So this speed of U2 is equals to 0. A is moving towards B with a speed of 6. So this is going towards B, and U1 is actually 6. Whole mechanics depend upon this data. If data you put a wrong, become wrong question answer. So best idea, read and write. Okay. After collision, the speed. Okay, after collision means this is before collision. Okay, this is before collision. Before collision. Okay. Now I will do the whole thing. Okay, 1 minute. This is after collision. Copy and paste here. Okay, and after collision, this is after collision. He says second number, the speed will be different. You know it very well. He said after collision, the speed of A is 1.5 and B is 3. Okay, so A is 1.5 and B is 3. So this is speed V1 is 1.5 and this is V2 is 3. But he mentioned here two possible values. You know, there are two possible values because mass of B unknown, we don't know. And you know the concept, if the mass of A is bigger, the mass of A is bigger, mass of A is bigger than mass of B. You know what will happen, students? Because a heavy particle will hit and both will go right side. But if a smaller mass will hit with a heavy mass, so smaller will rebound. But in this situation, I taken mass A is bigger, so both will go right inside. Okay, so let's try to solve it. And ultimate target is to find two possible values of kinetic energy loss. So first of all, our target is to get the two situations we have, and because unless we don't have the mass, we cannot solve the question. Okay, so what is law of conservation of momentum is very clear. The law of conservation of momentum is m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. I think idea is clear. So 4 into 6 for mass is 4, 6 speed. Okay, 0, so no need to write. M1 is 4 into 1.5. I think clear, 1.5. And mass is m into 3, m times 2, 3. So if you look at carefully, this is 24, and it becomes 6, m plus 3m. So I think this idea is clear. And I need to find what? 24 minus 6 and divided by 3. So mass becomes here is a 6. Mass finally get it 6 kilogram. Okay, so mass is clear. Now let's go for further. What is the next plan? Okay, so mass is here. In this option is 6 kilogram. Now, how we can continue? Because we need kinetic energy loss. So what we'll say here before and after. Kinetic energy before and after. And what is the kinetic energy before is very clear. Because you know, formula is a half mv square, half mv square, kinetic energy. So mass is 4 and speed is 6. So half So 2 into 36, it's giving us 72 joules. So I believe this is okay. Okay, and now I've talked about kinetic energy of the whole system after collision. But there are two masses because its speed is 0, that is by no participation. But here we have both there. Half into 4 into 1.5 square plus half into mass is 6, half mv square. I think idea is clear. So this 2 times 2, 1.5 square and plus. So 3 times 2, 3 to power 2. It is giving us 31.5 joules. And what is the loss? So loss of kinetic energy is very simple. 72 minus 31.5. And loss is very clear. 72. So answer is coming 40.5 joules. So condition number 1 is completely over. And now we will try condition number 2. Same situation we have. 1 minute, maybe space problem. So I drag slightly up. Okay. Now let's talk about, and this the middle line, make it here small. All right, this is clear. Now same story we will make for the other. So our best idea, I will make this diagram, but the situation will be reversed now. Not reverse. I mean, some part is. So let's talk about this. Okay. Now in the situation, if MA is smaller than MB, so naturally the mass of B is bigger. This mass is bigger. And what is the rule? When smaller particle hit with a bigger particle, it will rebound. So it means only one thing change. This arrow, it will come reverse. I think idea is very clear and restful because what is the logic? Logic is what here, when we have observer's eye here. So you know when particle going away from observer velocity positive, coming back to observer velocity negative. Now it's coming back to observer, so this velocity becomes a negative. So I'm writing not 1.5. I will write here negative 1.5. Although I can write it later, but I think it's also okay. Now, what is the formula? M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So mass is a 4 times to 6 and 0, and 4 times to 1, negative 1.5, and 3 times to M, or M into 3. So I'm getting what here? This 24, and this is a negative 6 will come here, come plus 6. So mass is turned to, because it's 30 divided by 3 become 10. So 10 kilograms mass. So I got this mass 10. Now I'm looking for the loss in kinetic energy. So I write before and after. Before and after. What is before? So you know kinetic energy formula have mv squared, that remains same. What I got before, 4 into 6 square, and that answer is coming 72. So it is not changing, like the same. But this one will change. So kinetic energy after collision. So what are the values? I'll take it half into, okay, this is because velocity will not affect here, only mass is 4 into 1, because even I take a square of this negative 1 point, so become positive, so not a big deal here. But problem, only mass will change. With before 6, now 10, and speed is remain same. And now if I type in calculator, half into 4, I mean 2 into 1.5 square plus 5 times 2, 9. And I'm getting here 49.5 joules. Then what is the loss of kinetic energy? So 72 minus 49.5. So if I subtract, my answer is coming 22.5 joules. I believe the point is very, very clear. Nothing hard, only planning, well planning, and this is the only important thing. And I think the concept is very, very clear, and the question is completely over.